Agriculture 4.0. So for that, today to discuss these important matters, these interesting topics, we invited a special personality as our chief guest. So he is Mr. Chaturanga Bopetta. Today we are pleased to welcome him to this great session, and also he will be sharing with us his expert opinion on this agricultural revolution sector. So I invite you all, please join with us, stay tuned with us to grab this valuable opportunity. So before moving to our main session, according to the agenda, I would like to invite our President, Robobull Society, Faculty of Agriculture, University of Peradeniya, Mr. Chandra Guruparachi, to welcome the gathering.
Thank you, Tusita. Good morning, all of you. First of all, I warmly welcome all the staff members from the Faculty of Agriculture, especially our Senior Treasurer, Professor Sanath Amaratunga, Professor Maujud, Professor Dayavansha, Dr. Patnaraja, and Mr. Razi Kaberatna. And it's my pleasure to welcome all the other participants as well for this webinar. And I must say it's quite nice to see such a large number of participants as well. So as the Robotic Club of the faculty, we thought of introducing the new trends and techniques used in agriculture. So we plan to conduct series of webinars with the collaboration of pioneer agricultural companies in Sri Lanka. So as the first step, it's a great privilege to start our inaugural session with Mr. Chaturanga Bopetta, the Assistant Manager of Factory Equipment Division in Hellis Agriculture Holdings Private Limited, as the resource person for today's webinar. As the Robotic Club, our heartfelt gratitude goes to Mr. Chaturanga Bopetta for accepting our invitation, and I'm pretty sure this will be a nice and interesting session.
Thank you very much. So guidance is an essential component to make every event success. So our Senior Treasurer, Professor Sanath Amaratunga, always encourage us to do this type of works. So now I would like to invite Professor Sanath Amaratunga, Senior Treasurer of Robobull Society, Faculty of Agriculture, University of Peradeniya, to address this audience.
Good morning to you all. The President, Chamika and Chaturanga. I'm very happy that the progress you all are making with this society. Actually, I didn't believe that the initiation of this society will go this far in a very short period of time. And also, it's a timely thing. Now, we are in a fourth generation industrial revolution where the electronics is the main focal point. And also, if you look at the history, now we started with the agriculture, and throughout the whole period, agriculture is keeping that focus, right? So it's developing, and all the countries, all the developed, underdeveloped, they all are paying much attention for the development of the sector, agriculture. Now, the other sectors, if you look at, say, the machineries, actually the machineries, they started the need of the machineries again for the agriculture, first for the land preparation, then for other purposes, and then the machineries are came into normal day-to-day life like vehicles and other things. So everything related to agriculture. Then we entered into era of communication. The field of communication developed so rapidly, so that it went above the communication and entered into other fields also. Especially again, the agriculture is the main focal point. So in this fourth generation industrial revolution, again, electronics became the major, and still the use is again for agriculture. So now we are focusing on how to use these newly developed technologies, especially the electronics, into agriculture. In the 70s, right, if you go back, we started electronics with vacuum tubes. They are like glass tubes, and inside we accelerate electrons and control the flow of electrons. So that was the electronics. And then in 70s or early 60s, the transistor came in, and then we went along that line. So the main difference between these two is vacuum tubes are voltage operated, the transistors are current operated. So there are advantages in voltage operated ones also, but little by little disappeared because of the cost, not because of the quality. So still the vacuum tubes are used in special occasions, like say in warfare, right? In warfare, you have to face a lot of harsh environments which the transistors cannot withstand. And also for high quality sound, still we use vacuum tubes. So don't forget these historic equipments while you are progressing with the newly developed technologies. And again, the other thing that I want to emphasize is that little by little, this sector is becoming very easy and also cheap. So in the past, to get a thing done, you have to solder a big circuit, right, with large number of parts. Now, little by little, this soldering is disappearing because these modular electronic components are now coming into the market. So it's very easy and fun. So even new student entering into the field can carry on their work to a very high level in a very short period of time because of this modularity. And also the programming. I should say a few words on programming. You know, we started with the languages like assembly and basic. Still they have their advantages, but with they are basically called the procedural language because we write a program as a procedure. So it follows just line one by one and does the job. Now everything is modular, right? The programming also modular. So things are very easy. You call the module and send the parameters to the module. So the module will do the necessary calculation for you. So in the past, I am talking about say in 90s, even in 90s, the electronics, teaching electronics was very difficult because of this thing. Because you need a lot of soldering, a lot of basic level programming. But nowadays, I cannot see the students are soldering things because they are modular. And also the programming languages are so in high level, they just use the modules and get the things done. So with these advantages and the prices are going down, the components, so it's now time to apply this good technology in agriculture. So I am again thanking you all for organizing this kind of very valuable seminars. Actually, Chaturanga is a product of our department. I think I taught him during his undergraduate period. And also I am very happy that he is now taking a lead in one of the leading companies, especially in this electronics sector. So thank you very much, and it's now time to start your session.
Thank you very much, sir, encouraging us for this type of important events. So now we are stepping into the our main event, that is about our guest speaker's presentation. So he will give us a more valuable concepts, expert ideas on Agriculture 4.0, Agriculture Revolution, and under that drones in agriculture, farm robotics and machinery, remote sensing, and machine learning and analytics, such type of top trends which are driven to this type of agricultural revolution. So before that, let me introduce him to today's session. So actually he is currently working as an assistant manager of Haley's Agriculture Holdings Limited, and also he is working as a visiting lecturer of Uvavelassa University of Sri Lanka. So I'm pretty sure that he has more experiences, he has more knowledge on this particular section. So we are very lucky to hear him today and also see him today in this session. So by the way, I want to say that if you have any questions, problems related to today's section, you can post them in the chat box. Then at the end of the session, the sir will give the answers for them. And also with that, I hope you will give your full attention to Mr. Chaturanga. Help me and also help me welcoming him into this session. So today our chief guest and the main special guest speaker, Mr. Chaturanga Bodhana. So here now time for you to carry on your presentation to the session.
Hi, very good morning to all of you. Especially I should be thankful to the Robobot Society of Faculty of Agriculture, University of Peradeniya for having me here today. And also thank you for the great introduction. And I also didn't expect that much of our participants and the interest in this subject. But however, it is really nice to see that undergraduates and also the graduates are having more interest towards these new trends, because that will be a good sign in our agriculture future in Sri Lanka. So before I move into the presentation, let me give a very brief introduction about the works that I'm doing. So initially, I also have graduated from Faculty of Agriculture, University of Peradeniya, and specialized in agricultural engineering, the same department. So I'm very pleasure to welcome me again to the same department session. So, and after that, I'm a chartered marketer in the Chartered Institute of Marketing, United Kingdom, so which is not related to this subject. And I'm working as an assistant manager to Harris Agriculture, and my responsibility has two ways. One is the research and development of the agriculture technologies. And secondly, I'm responsible for the marketing aspects of the such kind of products. Because I always believe that the universities and such institutes are making a lot of good innovations in Sri Lanka, but the problem is we are facing to a problem where we are not bringing those technology into the commercialization. So that is where I believe that I can fill that gap, because there are a lot of technological innovations and new inventions, like things the university students are making, but we have to bring that to the commercialization stages also. So that is why I always believe that the industry and also the universities have to be collaborate together like this and bring those technologies into the commercialization aspect. Not only in Sri Lanka, actually, we can sell those products or the services to even the other countries as well. So let me quickly bring you through the roadmap for the webinar today. So we will start from, as Professor Sanath Amartunga very correctly emphasized, that we should not forget the historical movements. So I was thinking that it is better to, as there are a lot of students or the undergraduates from the different verticals of subjects, I thought of sometimes some people might know already, but still I thought it is better to bring quickly through the history of the subjects also, because this is a very beginning to this subject. And also I believe this is the first webinar of the series of the webinar that the Robobot Society is going to conduct in future. So to get an introduction to this subject, I thought of give you some brief introduction about the Industry 4.0 first, and secondly, move into the Agriculture 4.0. And thirdly, I'm planning to talk about what are the driving forces to Agriculture 4.0, basically why we need Agriculture 4.0, whilst we have a lot of other technologies, why this is high time for us to move to the Agriculture 4.0 technologies. And also fourth step, I'm going to discuss about the driving technologies. What are the key technologies? There are a lot of technologies, but I don't think that there are enough time for me to discuss all the technologies, but at least to bring few technological, advanced technological things which are driving Agriculture 4.0. And finally, to discuss about the applications of those technologies, especially in Sri Lankan context. So there are a lot of applications in the world, but what I really want to emphasize here is what we have done up to now, and that is where the undergraduates have to bring forward from that point onwards. That is the whole purpose of having this kind of webinar, is to understand what we have already done and also bring those technologies in front. Okay, so before we go to the industry 4.0, actually it is better to have basic understanding about the industrial revolution. I know you already have read it, and also sometime you have learned this, but if there is anyone who doesn't understand or have not going through this knowledge, so I would like to bring him through this. So the industry 4.0 refers to a new phase in the industrial revolution that focuses heavily on the interconnectivity and the automation and the machine learning and real-time data. As you have heard that the data is the most valuable thing in the modern era, and therefore industry 4.0 also sometimes referred to as IoT, or the smart manufacturing, which marries the physical production and the operations with smart digital technologies. So if we go back to the industry 1.0, so the initiation of that, I think Professor Sanath also mentioned about this thing. So the 1784 started, and the mechanization, and also the biggest innovation of this era was the steam power. So with the introduction of the steam power, actually people started to revolutionize the manufacturing process rather than the manual labor that they had in those days. So this is the first industrial revolution. So mainly the sewing machines and those kind of inventions were there, but still the steam power was used as the main power source. That was the key invention those days, where the industry was revolutionized. Then if we go to the industry 2.0, so the mass production started, and the assembly lines, and also the biggest invention in this era was the electrical energy. The invention of electrical energy transforms the industry into a era where it had not been going through before. So those days it was the biggest invention, because people were able to use the electrical energy and transform their manufacturing process. For the best example is the second industrial revolution, as you can see on the screen. So this is the assembly line of the Ford Motor Company. So this is a very famous example on this second industrial revolution. So you must have already, you all have heard about the Ford Motor Company. The Ford is a very famous brand even in Sri Lanka also. Even when it comes to the tractors also, Ford brand is very famous in Sri Lanka. So Henry Ford, the founder of the Ford company, so he wanted to start an assembly line of the mass production of cars, especially the Model T. The car Model T was the very famous model. So he wanted to, his idea was to sell a car to each and every person in the country. That was the plan. So in order to achieve that, he wants to manufacture a car within a very short period of time. So that everywhere that he can reduce the time taken for the assembly line, so he wanted to cut it down. So this is the Model T, the car Model T. So he wanted to, actually even the paint of the car was only black, because the black color was get dried within the very short period of time even than the other colors. So that is how he has thought about the mass production those days, and also cut down the time that is taken to bring one car out from the factory. So this is, those days actually we usually call it as the production orientation, because people heavily focused on the production, but then it comes to the product orientation, because people wanted to have a different kind of product. So some people requested, I need a red car, I need a blue car, I don't want a black car because I like the color variations. So that is how they had to do the customization to the products. Then the production orientation became the product orientation. After that, it became the sales orientation. People believed that even though whatever the good product that you have, but you have to go in through aggressive sales procedure. But later on, you must have heard the Steve Jobs was the father of the marketing orientation. So the industry came to the marketing orientation. So again, the industry, if we see the industry 3.0, so that is basically the automation, computers, and electronics. So this is the biggest invention in this era, as Professor Sanath emphasized in 1969 or 1970s, the invention of the semiconductors. So that was the biggest invention those days. With that invention, the computer technology were developed. So as a result, there are a lot of automation things came in to the industry. So the third revolution, the industrial revolution, is starting in late 50s, and third industrial revolution slowly began to emerge. And as manufacturers began incorporating more electronics to these mechanical devices. So those days had a mechanical things, but now they are going to incorporate the electronic things also into the mechanical devices. Then eventually the computer technology into their factories. And also during this period, the manufacturers began experiencing a shift that put less emphasis on the analog and mechanical technology and more emphasis on the digital technologies and automation and also the softwares. So that is how the third revolution came in. Then industry moved to the industry 4.0, which is one of the subject that we are going to discuss today. That is the Internet of Things, IoT, and also machine learning, artificial intelligence. There are a lot of technologies involved with the industry 4.0. So if we go to the industry 4.0, which means the fourth industrial revolution, so there are a lot of applications like the mobile devices and IoT platform and 3D printing, smart sensors, big data analytics. As I told that the data is one of the valuable thing in today's world. So the big data analytics and augmented reality, cloud computing, and also on the other hand, machine learning, artificial intelligence, virtual reality, autonomous robots, and system integration, smart communication, and green energy. So these are few technologies that are being discussed when it comes to the fourth industrial revolution. So now let's see why we require to move to agriculture 4.0. So before that, I would like to bring you some of the statistics of the Sri Lankan agriculture situation, because now someone might be questioning why we need to have such technologies whilst we are doing agriculture, because we are basically agriculture country, so we are doing well with agriculture. So why we need to go for such advanced technologies? So if I quickly bring you through some of the statistics, our GDP, as you all know, 7% contribution to the only the 7% contribution to agriculture. To the total GDP, that is only 70% contribution from agriculture, and also the agriculture employment is close to 25%. But you can see the gap here. There is a big gap here because the GDP contribution is 7%, but our employed, 25% of our employed are involved with agriculture. So there is a huge gap there. So that is why we need to bring a lot of new technologies to get the maximum efficiency out of these labor, even to reduce the labor. Then, of course, we will be able to improve the GDP contribution from agriculture by enhancing the productivity of agriculture. And at the same time, we can bring down the percentage of employment in agriculture, where we can let these employees to involve with other technological or some other industrial kind of works. And if you see the exports of agri exports, that is 2.5 billion, which is 16% of the total export of the country, and imports, that is 1.6 billion, which is 7.2 from the total exports. And the agriculture land, also we are utilizing 43% of the total land of the Sri Lanka by 2018 for the agriculture, which is a very big area, a considerable percentage of the land used in agriculture. So that is where in order to improve the exports of the agriculture, we have to increase the productivity. That is where all these technologies are coming in. Now, let's see how the mechanization has evolved in Sri Lanka over a period of time. This is a bit of old data, but I have recent figures as well. So the four-wheel drive tractor actually we introduced in 1940s, and it was now in Sri Lanka, the four-wheel drive tractors, the big tractors, per year, the sales volume is like for 4,000 to 5,000 tractors per every year. So you can imagine, even though you are thinking that Sri Lanka is a small country, but you can imagine how much mechanization that we have gone through. If you go to especially the paddy, which is a major crop in Sri Lanka. So the whole, more than 95% of the land are already mechanized with these tractors. Because now what I really wanted to emphasize here to say that we have almost mechanized certain applications in Sri Lanka, but I'm not saying that all the applications we have already mechanized, but still there are other applications as well. But most of the key areas that we have already mechanized, but now we have to go for the other next step of this mechanization, because the mechanization is the machine, that is a physical machine. So what now we really want to do is to marry those Industry 4.0 technologies into these mechanical things, to digital things, and get the maximum out of the from these machineries in the field. So even the two-wheel drive tractor, which is the power tiller, so that is also actually it has drastically come down because people are moving towards the four-wheel drive tractor. The two-wheel drive tractor 5 years ago, there were like 15,000 to 20,000 tractors were imported to Sri Lanka every year, but now it has come down to like again 3,000-4,000 every year. Then threshers also introduced in 1970s, and now thresher are not used because the combine harvester is introduced in 2010, even before 2010. But now, when it comes to the combine harvester, also every year, like 800 to 1,000 combine harvesters are imported to Sri Lanka. So, but those almost all these machines are mechanical devices. So that is where the potential is there to do incorporate the technologies that we are going to discuss today into these kind of mechanical devices. Even the water pump we used to use from 1970s. So this is how the agriculture mechanization situation in Sri Lanka. So when it comes to any technology, let's say either agriculture 4.0, industry 4.0, or any technology like machine learning or whatever it is, there are drivers that will drive towards those kind of technologies. So these drivers we can divide into two parts. One is the trends. The other one is the disruptors. So the trends are very slow, but disruptors are very quickly affecting. So if you see few trends in agriculture sector in Sri Lanka, the one is the population growth, because the requirement for us to feed the nation. So that is, agriculture is there. Someone mic is on. Could you please switch off your mic? Okay, so trends are slow, but the population growth is slow, but in future that will have an impact because we have to feed the population. So that is where the challenge is. That is another driving force that we are pushing towards the agriculture 4.0. Then the income growth, as a result, actually as a result of the income growth, if you go back to 1980s, now the income is drastically increased in Sri Lanka also. So as a result, our food consumption patterns also get changed. So people used to eat different things, but they have not used to eat before with their income. So that is where, again, the agriculture also get one way it is a demand, but on the other hand, they have to produce the required food products to the market. Then the urbanization is also another driver, which is slow, but still it also reduced the lands which is being used for agriculture industry. And again, the urbanization, as a result of the urbanization, the lack of interest in agriculture. Now you can see labor shortage is also heavily affecting the agriculture industry today, because due to the urbanization, even the village people, the young people, they are not interested to get involved in agriculture industry. So they want to move to the cities and do other jobs. So that also become another driving factor which we needs to move towards the technologies. Then when it comes to the disruptors, so those are very quick things. So let's say a technological breakthrough, like a new invention, the completely new invention came in, then that also become a driver. But again, we have to change the industry accordingly. Then other thing is the pandemic. So these days we are experiencing a COVID-19 pandemic. So this is not a slow thing. So this is a very quick thing. So that will be affected the whole industry within a very short period of time. So when there are such drivers also, we have to find out solutions, how we can do the same production without disturbing the ecosystem that we had early with the new technologies. So COVID-19 is one example, and even the other diseases which is affecting to the crop, brown plant hopper, you might have heard the fall armyworm also was a pandemic in Sri Lanka. In such situations, so we have to act with the technology to address these kind of problems. Then the policy changes. So the radical shift in government policies, let's say that is also not slow. It is a quick movement. For example, these days now we are experiencing that the government has taken a decision to ban the agrochemicals and agrofertilizers. So in such situations also, we have to bring the new technologies, how we can address and also do the agriculture according to the policy that the government is bringing in. So it's a different matter to discuss whether it is a positive sides and the negative sides of that decision. But I want to say, when there is a decision taken, so the new technologies should be involved to address these problems and have the same production as before. Then let's see, there's a nice saying by famous author Deepak Chopra. So all great changes are preceded by chaos. So even the pandemic, even the government decision, whatever it is now, the great changes are preceded by chaos. Now, from the pandemic side also we are in a chaos, and the other sides also we are in a chaos. So it is a good time for us to think what we can do. Then if we see the post-pandemic effects on agriculture in Sri Lanka, so that is also very favorable towards the title that we are going to discuss today, especially the agriculture 4.0. So there are a few negative impacts. There are a few negative impacts. One is the food losses. So the increased level of food wastage due to the market closures. So, you know, due to the pandemic, so the market is closed. So the food wastage is there. So there is no proper ways to handle the yield that we have. So if we have a system like can be a mobile application or whatever it is, then to manage those yield, and if there is a data transferred from the field to the consumer, so it is easy for us to reduce such negative impact in such situation like this pandemic. Then the import restrictions for agriculture commodities also there. So some of the, for example, groundnut is banned to import to Sri Lanka to encourage the local production. So in such cases, also there are some impacts to the agriculture sector in the country. And also the agri inputs also restricted by the government. So as a result, so now we have to find out new ways to overcome these problems. Then the lack of financial support also in Sri Lanka, because as a result of the economic stress in the country, so there are lack of financial support towards the agriculture development in the country. So that is where we have to find out ways how we can do the agriculture with a minimal inputs of the agri inputs. Then the supply chain also get affected as a result, you know, the shipping lines also get delayed. So if we want to import something or export something, so we cannot rely on the shipping lines because there are a lot of delays these days, and also the cost also has gone up largely of the shipping lines. So the supply chain also get affected, not only the shipping from country to country, even the internal local transportation also get affected when the travel restrictions are imposed by the government. So all these things are the negative impact of the current situation, but that is where you as undergraduates, you have to think towards and bring new solutions for these kind of problems in future. So now let's move into the fourth agriculture revolution. So now we discuss about the Industry 4.0, how we arrived at the Industry 4.0, and now how we arrived at the Agriculture 4.0. So the Agriculture 1.0, which means the first revolution of agriculture, is the usual agriculture, the conservative agriculture practices we used to do in those days. But after that, the second revolution is the mechanization. After the World War I, so the mechanization, which means the introduction of the tractor, combine harvester, those kind of machineries came in. So as a result, the productivity increases drastically in agriculture fields, and also the labor consumption for agriculture also reduced drastically as a result of the introduction of these new machineries. But again, the third revolution comes with the green revolution. That is, after the introduction of the genetically improved varieties and also the commercial new fertilizers, chemical fertilizers. So introduction of these kind of technological products. So the green revolution, which means the third revolution, took place. Now we move towards the fourth revolution of agriculture, where we have the machinery, we have the genetically modified varieties and everything we have. But again, the people involved in the agriculture is coming down. So the yield and also the income of the farm also coming down. And also we have to feed the growing population. So now we need to come to the fourth agriculture revolution, which is the Agriculture 4.0. So now we will discuss some of the technologies that are involved with the Agriculture 4.0. And if we go to the fundamentals of the fourth agriculture revolution, so the definition of that given by the FAO, Food and Agriculture Organization, the fourth agriculture revolution is a marriage between data, technological innovation with farming that will further transform the industry and help us to achieve a new level of productivity, quality, diversity, efficiency, and environmental sustainability. So it covers almost all the aspects of the practices that we want to do. So according to that definition, we have to further increase the productivity and also the quality by diversifying and increasing the efficiency. And also at the same time, we have to see the sustainability of the environment. So before we discuss about the trends and also the disruptors, now let's see what are the trends in the global trends that we are bringing towards the 4.0. Agriculture, the rise in population, I already explained it, but according to the UN FAO report, so by 2050, the total population of the world will be close to 10 billion. So, which means we have to increase the food production, and at the same time, we have to see it in the positive way that there is a huge demand for agri-products, which means if we can enhance the productivity, definitely the agriculture industry will be having a very good income for the farmers also. Then the decline in farm income is another problem that we are facing. So as a result, only we have to minimize the agri inputs and also optimize other inputs supplying to the agriculture industry. So that is how we have to address these problems with the new technology. Then the very important thing is the digital native of consumers. So there are rising generations of digital native, and also most of the young generation are very tech savvy customers these days, both because that is the reason why even the Sri Lanka, if you go to the field, because our young generation is not involved with the agriculture. They don't like to go to the field and do some farm operations. But when it comes to the mechanization, most of these tractor operators and also the combine harvest operators are young people. That is because they are very tech savvy, and also they like the technological and also the mechanical things. But even going beyond, the new generation is very digital native because they really like to work with the digital devices. So they are getting, let's say, if they want to buy any device, a mobile phone or whatever it is, they will go to the internet and order it online. But when it comes to the agriculture product, so it is still not developed up to that level. But the customer is expecting to have such kind of a easiness to use their, to order their food by their fingers. That is what their expectation. So to bring that, so the digital native customers, consumers are there even in the agriculture sector. So that is also driving us towards the agriculture 4.0. Then digital disruption and consolidation. So the agri inputs, retailers are facing pressure from the increasing consolidation in the seed and the crop production industry, and from changing demand from the digital native customers. Then the traders don't have a foresight into the crop volume and also face highly volatile prices. So to manage that, also we can bring some digital technologies. Then again, food loss and waste. So that is also, it can be the post-harvest loss, and even it can be the loss from the consumers. So whatever it is, finally, the food wastage has increased drastically over the last period of time. So that is also another reason why we need to optimize the usage of the food product, because if you go to some of the poor countries, actually people are dying without food. But if we can have some sort of a technological applications where we can optimize the usage of food and also to optimize the spread of the resources towards each and every person, so that will be definitely will help to reduce the hunger of this world. Then let's quickly have a look on the agriculture value chain of the world. And this is applies to even Sri Lanka also. So the input companies like us, Aries Agriculture. So we provide the agriculture inputs like the machineries or seeds or fertilizer and other solutions also. Then there are farmers. Then farmers are doing the cultivation. Then the product goes to the trading and the processing companies. They do the processing or sometimes the trading. So the middleman is playing here. And then it goes to the food company. So they do the final product. Then it goes to the retailer, finally to the consumer. Then covering all of these things, there are service providers like finance, insurance, and research and development. So they are in all these stages of the agriculture value chain. Then the institutional enabling environment like policy, research, and educational institutes like universities, the policymakers like governments, those institutes also, they are across the agriculture supply chain, because the understanding of the supply chain in the industry is very important for us to find out solution for each step of the value chain. So if you are trying to solve any problem, so first you have to study the value chain. So that is what really important. Then journey to agriculture 4.0. So we will see how we are driving towards the newest technologies. First, we have the product. For example, let's say the tractor. So we have the tractor, then it becomes a smart product when we are introducing a digital device into this tractor. For example, let's say if you introduce a digital device which can see the performance of the tractor, fuel level, or the productivity, whatever the information that you can get through a digital device, that becomes a smart product. Then let's say if you connect that digital device to a mobile phone like today's, so even today everything is connected. If you see the air conditioner in this room is connected to my mobile phone. So that is how the connectivity works in these days. So the smart connected product is when you connect this digital device into your mobile phone, then remotely you can monitor what will happen in the field. Maybe the operator is working there in the field with the tractor, and you can observe what is happening with your machine from home. So that becomes the smart connected products. Then the product system. So the product system is, to your agriculture machine, you connect a planter or a seeder, let's say. Then the combine harvester is there, and the tiller is there, and also other attachments are there. So all are connected. Then it becomes a farm equipment system. So the system is the connecting of few other machines or the devices together, and it becomes a system. After that, the fifth level of the technology is the system of systems, which means you have the farm management system, which means there are few farm equipment systems, few systems connect together and make a farm management system. For example, let's say the farm equipment system, which we discuss in the fourth stage. Then let's say the weather data system. So we are going to discuss about this later on. The weather data system. So you know when to do the cultivation, when not to do the irrigation. So you have the weather data, and based on the weather data only you do the management practices. Then you have the facility system, and then we have the seed optimization system. So connecting all together, then you have the farm management system. So with this farm management system, you are able to get the data, and based on the data, you can take the decision, and based on that only you do the application. That is how you can optimize the whole process of agriculture, reduce the agriculture inputs, and also the efficiency also increased with such thing. Okay, now, up to now, are there any problem? Let me quickly check the chat box whether there is any problem. No, there is no any questions being asked yet. So we'll move to the driving technologies of agriculture 4.0. So we will quickly go through a few technologies. So there are a lot of other technologies as well, but here what I'm going to discuss is only few technologies. So first of all, we will see what are AGVs. So the automated guidance vehicles. So this is also used in the other industries. For example, I can remember when I was visiting the Kubota tractor manufacturing plant in Japan, Tsukuba. So they are using these AGVs everywhere in the factory. So no labor is required to bring the mechanical parts to the required place for the assembly line. So that is how they use the technology, because the AGV is used in a different industries, especially in manufacturing industries. So the most of the AGVs are indoors, but now for agriculture, there are a lot of new AGVs are being developed even for the outdoor applications. So, and also even inside the greenhouses, they are using the AGVs. So what AGVs do, so automatically those vehicles are guided. So it can bring necessary agri inputs to the required place. So you don't have to bring everything to everywhere. So wherever required, only you will bring that agriculture input. It can be a fertilizer, it can be a seed or whatever it is, then you can transport across the field using these AGVs. So the advance here is the without human interference, you can do that because you can monetize it from somewhere, because the labor is, then you can cut down labor. Especially for greenhouses, this technology is using in other countries. But in Sri Lanka also, I can remember University of Moratuwa developed one AGV for agriculture input supply. There were a few shortcomings in that technology also, but now they are still working on that project, I think. So similarly, we can understand what are the problems of those kind of technologies, and we can find solutions to bring these kind of technologies in. Then AMRs, so autonomous mobile robots. So this is also very important, because even inside the greenhouse or even outside the greenhouse, even outside fields, you can use these technologies. So these mobile robots you can use to do the seeding or transplanting, or even the weed removing also. With the image processing, you can identify the weed from the crop, then you can remove it with this robotic arm or even some other applications. Then even applying fertilizer or agrochemical also can be done through these kind of machines. Then even the crop can be detected. You can take necessary images, and also you can detect what are the problems in the field. So if there is any outbreak, or if there is any disease or a pest attack, so that also you can detect through the autonomous mobile robots, because the robot can take pictures and also analyze that remotely. Then the soil sampling also can be done. So if you want to get a soil sample and analyze the soil sample, that is also possible to do with this kind of technologies. Then even the harvesting also done up to a certain extent, that is being developed in the world, not for all the crops, but some of the crops, they are using these autonomous technologies to do the harvesting. Then agriculture drones. So agriculture drones, we call UAVs, which means unmanned aerial vehicles. So usually we refer to the term as drones, but there are so many kinds of drones. But the agriculture drones, when it comes to especially the spraying, the drones are there, and also the other type of drones are also there for the monitoring purposes. So when it comes to the benefit of these kind of technologies, so that is reduce the chemical application, because you can apply only to the places that really require, rather than applying a blanket application to everywhere. So you can have a customized application of the agrochemicals, where the environmental benefits are also there, and on the other hand, there are economic benefits as well, because you can reduce the amount of chemicals that is being used. Then the reduced water consumption. Water consumption is also reduced, because we apply only to the places where really required. Then reduced energy consumption. That is also because you apply in a customized way, rather than applying to everywhere in the field. But the challenges, there are few challenges. So this is the common challenges, but when it comes to the practical application, I will explain you the practical challenges that we faced when we are trying to adopt this technology into Sri Lankan context. But in this stage, what I'm discussing is the global situation. So one challenge is the regulation, because there are no flight paths. If we take the aeroplanes, so the flight paths are there. So they are flying according to the paths. But in drones, let's say if all the people are trying to use the drones for their applications, so this field person is also using a drone, and the other field guy also using a drone, and there are no flying paths, then there are crashes, and also the damage to the humans and also other resources also will take place. So the regulations are the problem. When it comes to the Sri Lankan situation also, is still the government regulation is such that it restricts to flying bigger drones. So we have to go through a series of approvals in order to fly big agriculture drones. So that is also the regulation problem when we adopt in these kind of technologies in Sri Lanka. Then the other biggest problem in this technology is the battery or the flight times, because most of the drones have a very low flying time. It's like 20-30 minutes. So which is not enough, because then again, you have to use a very big battery, but with the weight of the battery, it is difficult to apply these kind of batteries to these technologies. Then the applications, mainly the drones are being used for the mapping and surveying. So you will sometimes have some experience to get the image of the field, and also, let's say, the counting. In Sri Lanka, even the rubber plantations, they are using this technology to count the trees. Let's say the coconut plantation, they want to count number of trees, then they will take a image, a bird eye view from the top, and they will do the counting. So similarly, these kind of surveying can be done using this technology. Then the other application is the selective crop dusting or spraying. So that is the vastly used application in the drones in the world. So then the remote sensing. The remote sensing is also a new technology that are being used in the agriculture 4.0. Plenty of remote sensing techniques are there, from in field sensors to the drone to satellite imagery, allowing farmers to view their crops from multiple perspectives, which means in a different thermal images or the different color images they can take, and based on those imagery views, they can take different decisions. For example, this picture also shows in Saudi Arabia, the fields where the pivot irrigation systems, a lot of pivot irrigation systems are being used. So with this kind of images, they can take a lot of decisions based on that. With advance in the computing and sensor technology, farmers also now can get access to the high cadence and broad area coverage with field level details. All these provide farmers up-to-date information in real time. So changes can be made according to their crop. The decision can be made according to the situation of the real field, rather than doing a usual management practices. Because nowadays, with these technologies, we don't want to follow the usual practices. Then we can apply only wherever necessary. Then another technology is the vertical farming. So that is also, when it comes to the agriculture 4.0, that is also very famous thing, because most of the countries now are having very reduction in the agriculture lands. So what they want to do is to increase the efficiency within a given area. So they have to improve the yield in a given area. So what they are practicing is the vertical farming. The benefits is the yield growth is 24 hours in 7 days. So the yield growth is there. Now, unlike in the outside field, where you get only the sunlight duration, the daytime, but here in the vertical farms, you will get the growth 24 hours, because you artificially provide the necessary lights and also other inputs to your crop. Then the protection against adverse conditions also there, because mainly these are covered like greenhouses. So you can protect that from the adverse conditions like, let's say, heavy rains or heavy sunlight, whatever the adverse condition that you can protect. Then the small space requirement is another benefit, and the less water consumption. You know, the agriculture is the highest water consuming industry in the world. So with this technology, you can reduce the amount of water consumed in agriculture industry. But when it comes to the challenges, the high capital cost is the biggest challenge that we are facing in vertical farming, because only in the developed countries nowadays using this technology vastly, because we have to invest a lot of money to start. The initial investment is very high in vertical farming. Then the immature technology is another problem, because our people are not get used to these kind of technologies. But fortunately now our farmers are a little bit aware about the greenhouse technologies, and even there are a lot of greenhouse farmers even in Sri Lanka. But in time to come, we believe even for the vertical farming also now few people have already started, few companies rather, have already started the vertical farming in Sri Lanka. So we believe in near future there may be huge trend towards these kind of technologies. But on the other challenge is the large energy requirement, because you have to provide the light throughout the day. So that required a lot of energy, and this application is inside protected agriculture. The next technology, in this stage, as I explained here, what we are discussing only the technologies, but later we will come to the real-time applications. The machine learning is basically, most of you must have some understanding about what the machine learning is, but if someone is not having any understanding, let me explain very simply what machine learning is. Let's say if you have a mobile application to detect the crop disease. So let's say you have to identify a particular bug in the crop. So you will feed a photo of that bug to your phone, let's say to the software or the application, the mobile application. So once you take another picture of the same bug, so that system will run the image processing, then compares the colors and also the sizes, shapes, dimensions and everything, and it will give you a result saying this bug is also almost similar to that bug. So the mobile application can tell you that this is the bug name is this, because before that you have feed that information to the system. So it compares with the available picture and give you a result that, okay, this bug is also similar to the bug that is being fed before, and he can give you the name of the bug and also the other details. Otherwise, let's say what we are practicing is we have to keep in our mind what is this bug, the name of this bug, why it has happened. Then it is really difficult for us to identify. Then as a result of not identifying correctly the bug or the disease or whatever it is, then we are not taking corrective measures in the field. So having such technology can improve and also reduce the amount of work that you have to, effort that you have to put to do the agriculture, because even the person who doesn't have a very good experience in agriculture also can do agriculture, because with the help of such devices. So as far as the machine learning concerned, what will happen, previous example, if you go back to the previous example, so again, now let's say to the device you have fed only one picture of the bug. Then you will take the second picture and the system compares both pictures and give you the result. Then next time when you are taking a picture, so it compares with the both of the pictures that is there inside the system. So now in the database there are two pictures. So in order to compare, that will give an accurate result, because now the system has two pictures to compare. Then it comes to the next time. So now the system has three pictures to compare. So that is how the learning, we also, learning is that we also learn certain things, then we will keep it in our mind, then we will learn something else, then we verify what we have learned before, then our knowledge becomes very strong. So that is how we also learn. Machine learning is also the same process which is doing by a machine or a computer or a mobile phone or whatever the digital device. If the machine is doing it, then we call it machine learning. So that is the simplest explanation. I know it's a very big subject, so this is not the time. As a very beginning of this webinar series, this is not the time to discuss in detail about these kind of technologies, but in future we hope that we can do such webinars also, and even we can introduce some other experts in the field. So this is just an introduction to these kind of technologies. So simply that is machine learning technology. So blockchain, this is also very, very interesting area where the agriculture 4.0 is concerned. It is very new to Sri Lanka, but still there are companies, this technology is being used even in agriculture also. I'll tell you those companies later on. So this is really important to understand the basics of this technology. So the blockchain is a technology which is being introduced by a Japanese person. So this technology is the one which is behind the cryptocurrency. So I think you all, the young people, must have heard, and also some of you have already doing some works with the cryptocurrencies. But what he really wants, if like machine learning, if I am very simply explain what blockchain is, because without understanding these technologies, it is difficult for us to understand the future. The other slides, what I am going to present today. So the blockchain, if I am simply explaining it, let's say there is a transaction taking place between two people. So I am giving 1,000 rupees to person A. So there is a record in my mind, and also a person A's mind. There's a record that I gave 1,000 rupees to him. So that is the evidence we have on this transaction. That is the basic kind of transaction that we can do. When it comes to a transaction like two countries, let's say if I want to transfer 10,000 rupees to a person in US, in America. So, but again, let's say no need to go to America. Let's say if I want to transfer 10,000 rupees to a person from Colombo to a person who is living in Kandy, what I have to do, I have to do the transaction through a bank or any institute, a responsible institute. So that is how I have to do the transaction. Then when I'm doing that transaction, I will deposit money to a bank account of that person. Then the bank or that particular institute will keep a record about this transaction. So it is not in our mind. So the basic transaction is that what I explained, but now the record is being taken by that particular institutes. But that Japanese guy wanted to develop a technology where to cut down this intermediate. So let's say basically the bank or the institutes, the finance institutes. So if I do a transaction with a person, let's say with the digital technology, we can keep a record somewhere with this technology, with this transaction. So that is what blockchain technology is, simply. So there is no middleman involved, but each and every transaction is peer-to-peer encrypted, and also that is being recorded in the digital system. So you must have heard a term called crypto mining, cryptocurrency mining. So when he developed this technology, so now in world, this is vastly used. The technology is being used in different verticals of the technology, but let's come to the agriculture later. So what we really need to do is first to understand, basically to understand what the blockchain is and how does it work. So what that guy wanted to invent is a method to do a transaction, and it keeps a record and nobody can cheat. There is no any cheat is taking place because the each and every transaction is recorded somewhere and it is being verified by a few people. So the cryptocurrency mining is, in order to do that verification process, there are very complex, processing has to be taken in order to verify those transactions, because the transaction, it is not like doing a transaction a person to person. There are millions and billions of transactions are taking place. So it is a very complex system. So they need to do the verification. In order to do the verification, there are processors are required. The computer processors are required to run these complex algorithms. So what they are doing is, let's say if you give your processor capacity to run that algorithms and do the verification process, they will pay you a small amount. That is what the cryptocurrency mining is. So let's see what is the problem in the agriculture field, what we have to solve with this technology. So one problem is the disconnect between supplier and retailer, because the grower, supplier and the retailer, there is no connectivity. We don't know when you buy a 1 kilo of carrot from the market today, you don't know where that is being grown, whether it came from Nuwara or Valimata, you don't know. And even it is important from some other country, you don't know. So some details are missing. So you don't know whether it is organic, whether it is cultivated with these practices, you don't have that. And also the limited financing resources also have become another problem. Then the lack of transparency in food production and distribution. So there is no transparency. Anyone can say this is good quality thing and this is imported and this is grown in there, and anyone can say there is no transparency in the information flow in the agriculture section. And also again, the middleman, the farm gate price of a 1 kilo of potato is very low compared to the price of the 1 kilo of potato in the supermarket. So there are a number of middlemen are involving even in the agriculture sector, where they are getting a huge portion of the value, where finally the consumer is also paying a huge amount of money to buy. And at the same time, farmers are getting very low amount of, having a very low farm gate price for their products. So that is how the agriculture industry, the problems of the agriculture industry. So in order to address these problems, the blockchain can give you solutions. So the traceability for customers through these are the solutions, and transparency in food products and farming techniques. So with this technology, like what he has done to track the whole transaction, similarly with this technology, they can track all the practices, where does this come, and everything they can track. Then they expand financial options for farmers and provide immediate payment on delivery. Then again, the suppliers and they provide farmers with the direct access to the suppliers and transparent transaction information. So these are the solutions that we can bring with the blockchain. It's a question. Right. So this is the basic of the blockchain as I explained. So the blockchain is a technology that allows users to transfer value or assets between each other without the need for trusted intermediary. So similarly, as I have explained, without a finance institute, with this technology, you can do any transaction. So it is low cost, because if you're going through a bank also taking some amount of the transaction, because you have to pay a bank, let's say, some amount for the each and every if it is a online transfer, they charge. But when it comes to this technology, there is no cost involved for the transaction. Then it is anonymous. You can do it anonymously, and it is distributed and decentralized ledger, because that ledger or that information is available, because that is decentralized. It's not like if it is a bank, so it is a centralized, because the bank is keeping the record and all the information with them. But when it comes to this technology, it is decentralized. The information is available to everyone, and it is permanent and immutable. You cannot delete it. Nobody can go and delete that transaction detail. That is why we call it secure. Okay, so any question? Sorry. It seems there are no questions. So let me bring you to the things what we are doing in Sri Lanka. When I say what we are doing in Sri Lanka, it is not only our company is doing. I would like to bring some other technologies, other companies also have bring in. So first of all, I will tell you one project that we have conducted, that is automated weather station and disease forecasting model. We have engaged with a company called Adcon Telemetry in Austria. And we started this project, I think, in beginning of 2017, but still we are going through it, but we could not finish it because of the certain limitations. So the reason why I want to emphasize these kind of technologies to, we need some young people like you to come forward and take this initiative forward. And if there are interested parties to involve with these projects, so we would more than happy to take them to and work closely with the university to bring these technologies forward. So the automated weather station, actually what we have done, as I have shown in this picture, the left side. So we have a weather station which consumes a very low amount of power, and it has an inbuilt solar panel, a small solar panel. We install this system in Nuwara in a potato cultivation field. So we can fix few sensors or the monitoring devices like rainfall data, then wind direction, wind speed, RH, temperature, soil moisture, soil temperature. There are various kind of sensors you can fix into this single device, and it through a GSM module, it transfer data to a common server. So with that server, you can monitor these weather data. So from the weather in Nuwara now, you can monitor from Colombo. It's a simple technology. It's nothing to do with that very big technologies. But the real beauty of this technology is in Australia and Austria, and even in European countries, what they are doing is using these weather data, they have developed very complex mathematical models, which is run behind the computers. But through these mathematical models and also the predictive models, they are now the technology that we were discussing before, it is being applied here. For example, artificial intelligence and the machine learning also involved. So these technologies are being involved in the system, and they have developed some mathematical models to predict diseases of the crop. For example, let's say if you take the early blight in a potato, which is a very common problem, even in Sri Lanka. So that is a fungus. In order to fungus to grow, there are certain environmental conditions, the weather conditions. Let's say that fungus can make spores in this temperature, this range of temperature, and the RH has to be this much, above 80 RH only it is start growing. So there are so many different environmental conditions. Optimum conditions are required to that fungus to grow. Otherwise, the spores are there, the fungus are there, but it doesn't become a problematic level. It doesn't come to a problematic level unless otherwise those optimum conditions for that particular disease or the fungus or the bacteria or whatever it is, that optimum condition has to be there in the field for that fungus to grow. So what this technology does, it will record data over a period of time and see the disease level also. So disease data also being recorded. Then through the machine learning techniques, the system is being trained. Then in near future, that system will give you a prediction. When that optimum conditions are there in the field, the system will give you an alert saying your crop is vulnerable for this disease. So you need to take preliminary actions to protect your crop. So otherwise what they are doing is these days, fortunately, there are no agrochemicals for them to use. But otherwise, if you take a crop like cash crop like potato, they are using a lot of chemicals. So even other vegetable crops also, they are using so many chemicals. Overusage is very common in Sri Lanka. That is a common thing that everyone knows. But in order to reduce and also use whenever necessary, rather than using once in every three days, so they can use chemicals whenever necessary through this technology. With this technology, what we can do, we can produce a very product with a low amount of agrochemicals are used, and also the cost is also reduced, and also other labor for this application. The spraying is also labor consuming practice, so that is also they can reduce. So with this technology, so the European countries now they are using this technology. So with the same technology, so they have reduced the usage of so much of agrochemicals. What we are trying here in Sri Lanka to bring these mathematical models and do the validation of these models in Sri Lanka, because we cannot use the same model in Sri Lanka because that is trained under their condition, their temperature, their RH, so their environmental, under their environmental condition, only that system is being trained. So what we have to do is we have to get the same models and use it here, and also train these models according to the Sri Lankan context. So that project is also going. So still it is not finished, but it is currently it is stopped for the moment. But we are planning to start that project in near future also, and also similarly then farmers will get details like now your crop is vulnerable for this particular disease, you have to take this action. So that action is also, even government level also, they can take the decision. And if we can maintain a huge database of the farmers, so according to, if you can place a automated weather stations in a different places in Sri Lanka, then we can get a one place to do it, like government, then they can send a SMS to all the farmers in that area saying your crop is vulnerable for this crop, so you have to take these precautions to protect your crop. Okay, then drone spraying. We in Haley's Agriculture also we imported sample drones to Sri Lanka to test it in a different crops. We have tested in for tea, paddy, sugarcane, and also other vegetable crops. So we have tested for different crops, and also to observe what are the results of because even though these technologies are used in the other countries, but we cannot say those technology can be used even in Sri Lanka in the similar way, because our conditions are different, our field practices are different. So we have to do certain changes, and also we have to adopt these technologies into the Sri Lankan context, because our farmers are also a bit of reluctant to go for new technologies like this. So it is our responsibility to bring those technologies and train them to use such technologies. So the output of this technology, when it using for the tea plantation, the biggest problem is the shade trees. With the shade trees, you cannot program the system and run it without our interference for the spraying with the shade trees, the interruption of the shade trees. So similarly, even when it comes to the paddy also, with the huge winds coming down from the drone, because we have to run the drones at a very low height from the ground, because just to ensure that the even application of the chemical, then due to the wind, there are crop falling problems. So the other crops also, there are some problems. So we are also finding solutions for that. So that is why we are always trying to collaborate with the industry and also the university and people, those who are doing the researches in these areas, to how we can go beyond with these kind of technologies. But there's another technology that I want to emphasize when it comes to the drone spraying, that is the electrostatic spraying. This is not a very new technology, this is a very old technology. But what I really want to tell, to give you a brief introduction about this technology, and now we can see how we can incorporate these kind of technologies into the technologies like this. So as we discussed early, the agriculture 4.0 is not that we used only the new technologies, rather we used the existing technologies, the mechanical technologies, and we incorporate the other new technologies into the mechanical devices and get the maximum benefit out of those devices. Similarly, when it comes to the electrostatic spraying, what I want to highlight, so this is a very common technology that is being used even in other countries also, but in Sri Lanka, this is very new. But we have imported few samples of the electrostatic sprayers to Sri Lanka. So what now we are trying to do is, we are trying to see whether we can combine this technology into the drone spraying, where we can optimize the usage of agrochemicals. So if I'm explaining this technology briefly, so there is a electrified ring-shaped electrode, as you can see here, because the drone is also using a battery, so the electricity won't be a problem. So to the orifice or the nozzle of the spraying nozzle, there is a ring-shaped electrode, which is basically an anode. So it has a positive charge. So as a result, when you spray through such orifice, what will happen? The droplets. Let's imagine a droplet, and we will make it bigger for better understanding. Let's say a football size of a droplet that has the water and also the chemical that you are spraying. So that is a water ball. So that droplet, the bigger droplet, the making it bigger just to understand, right? So that bigger droplet, there are positive and negative charge in any kind of a water ball. So when that droplet is going through this electrode, what will happen? Due to the positive charge, the negative charge in the droplet will come towards the surface of the droplet due to the attraction to the positive charge. So the negative charge will be coming towards the surface of the droplet, and also the positive charge will be going concentrating to the middle of the droplet, because it is going through a electrode, an anode. So as a result, the droplet which is coming out through this orifice, the surface of this droplet is purely a negative charged surface. Purely a negative charged surface. When it comes to let's say the application to a canopy or any crop, if you take the microscopic view of any leaf of a tree, there are micro hairs. Even the upper side and even the lower side of the leaf, there are micro hairs. You know, in a hair, the tip of the hair, you know, this electric thing, you know, we used to do when you were childhood. So what we call, in each and every hair, micro hair, the tip of the hair is positively charged. That you know, I'm not going to explain that. So as a result, there are thousands of micro hairs on top of the leaf. So as a result, the whole surface of the leaf we can consider as a positively charged surface. So now our droplet is negatively charged. So the surface of the leaf is positively charged. So as a result, there is an attraction towards the leaf. So through this technology, what we can do, we can reduce the drift, which means if you do a chemical spraying, so nearly 40% of the chemical is going to the ground, not to the targeted leaf. So you can reduce that amount. So that is one thing. So you can use only a low amount of chemicals because you reduce the wastage, because it applies directly to the place where you target. So even the upper side of the leaf, also it will come like this. So there are images are taken when the electrostatic spraying are taking place. So some droplets are coming like this, and the pest, otherwise the pest can be hide underneath of the leaf. So if the droplets are coming like this and touching the lower side of the leaf also, then you can control the pest in your field. So this technology is used in the boom sprayers, like the bigger sprayers. But what we are trying to incorporate this technology into a drone spraying, then what we can do remotely, we can control the amount of electricity that we are passing to the droplets. So similarly, you can do certain optimization. So still we have not started it. I just thought it because there are a lot of undergraduates here, so who needs inputs for them to think and also develop new technologies, incorporating a few technologies together. So I just thought of bringing this technology also into this presentation, where they can start thinking, where they can start making something in future. So the pivot irrigation system is also another technology that we are importing, and we are the only supplier for the pivot irrigation system in Sri Lanka right now.
Yes, sir. There is 2 questions posted in the chat box.
Yes.
Can I present it to you, sir?
Yes. Shall we answer the questions at the end?
Okay, sir. Okay.
All right. Okay. The pivot irrigation system is also not a very new technology, but now there are a lot of new devices which is being fixed to these pivot irrigation systems, the electronic devices, where you can monitor remotely the performances of the pivot irrigation. Pivot irrigation system, basically, I know you all have some idea. The pivot irrigation system is a irrigation system where you can irrigate like 50-60 hectares at once. So there are few types of pivot irrigation systems. The basic type is the center pivot, which means there's a center point. So this is a picture of the recently installed pivot irrigation system in one of the NLDB farm in Sri Lanka by Hales. So we can do the irrigation for about 50-60 hectares at once with this technology. So this is a center pivot irrigation system. So there's a center point. From the center point, the irrigation system can rotate. The one rotation will take around 24 hours. So when it completes one rotation, it will cover 50 hectares, and at the same time, it will do the irrigation. So nowadays, there are some other technological devices which is being fixed to this kind of bigger irrigation systems, where you can monitor the irrigations and also the soil moisture and everything remotely, and you can decide when to do the irrigation, and even you can control the whole system through your mobile phone. So that kind of technologies are there. Even from the manufacturers, there are some technologies, but we are also planning to introduce some of the new technologies to these kind of mechanical irrigation systems. So in future, there are good potential for this technology also to introduce some of the new technologies to monitor and also take the decision based on the soil condition to when to irrigate and when not to irrigate. Then another interesting thing, so this is the Uberization platforms for agriculture. So this is actually, I observed when I was having a visit to India, actually I observed that some farmers are using some mobile devices to order their farm machinery like tractors. So I was start searching what are these technologies. Then I found that even in India, there is an application called Traxi, not taxi, Traxi. So then when I am searching, I saw there's an application called mobile app called Hello Tractor. So then I searched who has invented this. Actually, he was a guy called Jehail Oliver. So he's from Kenya. He's a young entrepreneur. So he invented this technology. So what he is doing it, you all know what is Uber or the Pick Me. So this technology is now very common to us. But if you go back to 5-6 years, this technology was not there in Sri Lanka. Even we also afraid to order our taxi through an application, mobile application. But now nobody afraid to book your taxi through the mobile app. So what it does, simply it will show you the available taxis around you and you can book one taxi then, simply as that. But the Uberization platforms in agriculture, what this guy, the Jehail, did actually, he introduced the same technology to agriculture, because you know, in agriculture applications, you need to do it timely. When the rain comes, you have to do the land preparation. You cannot postpone it. Unlike other applications, actually, you have to do it timely. The agriculture practices are such that you have to do it on time. Otherwise, there are a lot of bad repercussions are there. So in order to do that, if you have an application, mobile application, and you know, as I told you before, there are nearly 5,000 tractors are being imported to Sri Lanka every year, which means in the field in Sri Lanka, there are nearly 25,000 tractors. When it comes to the combine harvesters, there are nearly, let's say 10,000, 8 to 10,000 combine harvesters in the field. When it comes to the power tillers, there may be more than 50, 60,000 power tillers in Sri Lanka. So if you can bring a technology like this, so where the farmer enables to order a tractor for land preparation, because you know, in Sri Lanka, our land size is very small. One farmer is having only 1-2 acres. So it is not practical for him to keep a tractor for himself to do the land preparation over 2 acres. So what will happen usually, the people are buying tractors and they are hiring it for others, other farmers. The contract hiring is the common practice in Sri Lanka. But this kind of technology will help farmers to book his tractor or a combine harvester. But harvesting is also, they have to do on time. Before the rain comes, they have to do the harvesting. Otherwise, the crop will fall, and also there are a lot of problems, yield loss, and there are so many problems in agriculture if we are not doing it on time. So with this technology, it is really easy for them to book a farm machinery for them. So I had an initial discussion with the guy who has developed this technology, Jehail Oliver, and also his COO, Mr. Folu Okundane. So I had an initial discussion, I think few weeks ago, had an online meeting with them to discuss about this technology and how we can bring this technology to Sri Lanka. I think it's not a very big thing. It's just the bring that idea. The making this app is not a bigger thing, but adaptation that technology into our farmers is a challenging thing, of course. But I think as I have told you before, almost all these agriculture equipment operators are also young generation. If you go to the field, you will see the tractor operators are like 18, 20 years old young guys, and they are using the smart mobile phones also. So they know how to use this technology. So I don't think even in Sri Lanka, we are underestimating the penetration of technology, especially when it comes to agriculture. We are yet underestimating the penetration level. But I personally believe, according to my experience, because I'm going to the field, so according to my experience, I believe even this kind of technology will be bringing forward in Sri Lanka if we can introduce such technologies. So these are the new innovations actually. This young guy from Kenya, he is now a multi-million entrepreneur because of this small technology. So I had a discussion with him and it was a very interesting discussion. And also he said he would like to do the multi-franchising of this technology, but I personally believe we don't have to bring this technology from a country like Kenya. Rather, we can develop the same kind of technology in Sri Lanka. So we can work together. There may be interested people in this forum also. So even in future also, we can have another discussions and how we can bring such technology. This is just an introduction of one technology, but there may be some other applications also. So you can come across with various type of applications. Then this is another example that I want to bring you today. So this is the black tea analyzer. This is being developed by a company called Kawasaki Kiko from Japan. So this was a joint project with Hales Agriculture and also the Kawasaki Kiko from Japan. So earlier they have developed a tea ingredient analyzer for the green tea, but for the black tea, it was developed with the with the involvement of our company. So what it does, this is also involved with the machine learning, because what this machine does is the replacing the job of the tea analyzer, because the tea tasting is a very skillful job, so nobody can do it. There are very few number of tea tasters in Sri Lanka, because it's a very unique talent, and also it involves a lot of dedication to develop that tea tasting ability. So what will happen to remove that bias, because let's say it's a more of a subjective thing, because if someone say, okay, this tea is good, this tea is not good, so it's a more of a subjective thing. But if you can bring a technology like this, what you can do, definitely you will be able to do the uniqueness of the tea. So then we can get a good price in the world market for our teas, because through this technology, it analyzes the various components of the processed black tea, and based on the ingredient levels, it gives you a saying, this is now what we are doing is low Grovans, high Grovans, oolong, whatever the different type of teas. So with the ingredient levels, it will give you a quality certificate, like this tea include these kind of things. So this can be categorized as this tea. So this is OP, this is BOP, this is BOPF, or whatever the categories. You can do the categorization based on the ingredients of the tea. So this machine also needs a lot of training. So this is just introduced, but in future we have to, through the machine learning techniques, we have to train this machine also to give a better understanding, because we have to feed a lot of samples and let the machine to study the different samples and different ingredients of the tea, and finally do the categorization accurately. So this is another application. Now, up to now, I was telling about the technologies that we have done by our company, but now I'm going to move to the technologies that other companies have done. AIGROW is a subsidiary company of the CodeGen. So the same company which is developed the Vega car. Actually, I visited this place. This is located in Maradana. So the Dr. Beshan Kulapala is the project head of this thing. So I personally had a visit with him to this facility, because this is located in top of the Vega car warehouse. The Vega car warehouse is there in Maradana, and top of the rooftop of that building is developed for this technology. So they have developed a lot of local technologies like smart sensor systems, water recycle, reuse, and also advanced grow lighting system which you can monitor remotely, and also the fertigation system also they have developed, and also the intelligent data center, and also is scalable on demand. So I'm not going to talk much about this technology. If you are really interested, you can go to their website and also search. I also believe as young people like you have to always eagerly search for the knowledge. So even in Sri Lanka, you must not have even think that Sri Lanka is developing such technologies. But now you at least have some insight. Now at least you have some beginning to think. So what we are expecting you to do is to eagerly search for the technology, knowledge, and also there are enormous number of literature in the internet also. So you can search what the other industries has done, and then you can bring this cross-industry application to agriculture. And at the same time, you can search the technologies that are being used in the other countries and how you can bring those technologies into the Sri Lankan context. So AIGROW also have done marvelous job, and also they are doing a lot of works in the agriculture field, even though they have came from different verticals in the industry, but now they are doing a really good job. Dr. Beshan and also Dr. Harshad's team is doing a really nice job in this industry. Then these are their cloud-based IoT applications and AI application and remote monitoring. This the below picture, if you can see, this facility is there at Maradana. So in a small space, they are maintaining a really nice greenhouse with this great technology. So we have to be very proud of such technology are being used even in Sri Lanka also. So as agriculture faculty people, most of you are from, I hope, from agriculture faculties, and also maybe some other faculties like more to engineering faculties. So your responsibility is to bring more technologies in. So the next example, the final example that I want to bring is the Tracified. So that is also, you must have heard about a company called 99X. So they have developed this application. So this is another application which use the blockchain. So you must not have believed that the Sri Lankan companies are using blockchain in agriculture field. This is not one and only example, even though I have bring it today, there are some other examples as well. Tracified is an application where they are providing blockchain applications to trace. So the agriculture supply chain, so they are planning to launch, they have already launched this, and also even other countries like other country, they have already introduced this technology to other countries. But in Sri Lanka, this technology is not being used, even though this technology is developed in Sri Lanka, but they are selling that service to other countries, the supply chain in agriculture supply chain in other countries. So through this technology also, proof are keeping in every transaction. So it is in future, it is through this technology, you will be able to monitor the food that you are consuming today, where it has came from, and also where it is grown, and also how it has grown. And there are a lot of information will be available for you to have even in the agriculture products that you consume in future. So that is how the technology has evolved. So I have almost came to an end of today's session.
Thank you very much, sir. So now we are moving towards the end of this session. So I would like to invite the Secretary of Robowood Society, Faculty of Agriculture, University of Peradeniya, to deliver the vote of thanks.
Honorable Chief Guest, Mr. Chaturanga Bopetta, the Senior Treasurer of Robowood Society, Professor Sanath Amarathunga, all the academic staff members, and all the participants. On behalf of Robotics Society, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this webinar, Agriculture 4.0, organized by our society. At the outset, I thank our chief guest and the resource person, Mr. Chaturanga Bopetta, the Assistant Manager, Agriculture Equipment Division, Hales Agriculture Holding Limited, to take our time from his busy schedule to grace the event with this extremely relevant address, Top Trends Driving the Fourth Agricultural Revolution. I'm pretty sure that the precious knowledge that Mr. Bopetta gave us will definitely help us in our studies and future. Thank you, sir, for sharing your vast knowledge with us and make this day so special. I extend my gratitude to Professor Sanath Amarathunga, the Senior Treasurer of Robowood Society, for the support and guidance for organizing such an event. Thank you, sir, for assisting and encouraging us. I also wish to express my gratitude to Senior Professors Ranjit Premalal, Professor Maujood, Professor Dayavansha, Professor Benaragama, Dr. Padmaraja, Mr. Rasika Aberatna, and Mr. Chamik Anuradha for providing encouragement and support to us all the time. Further, I am very grateful to Mr. Nadun Viraj, who is a former member of our society, as well as an Executive Product Manager, Agri Equipments Division, Hales Agriculture Holdings Limited, for giving us an opportunity to organize this event. And special thanks goes to the organizing committee for their unflinching support and coordination to make this webinar successful. Finally, our heartfelt thanks goes to all the participants for their active participation. Thank you everyone once again for making it a great success. Krista?
Yes, thank you very much, Appa, to deliver the vote of thanks. So today we gathered many information, we gathered great experiences on this agriculture revolution side. So I'm pretty sure that you take a good and great benefits from today's session. So until we meet again through this kind of a productive session, today we are going to wind up the session for today. So thank you very much for your participation. Stay safe.